Video problem 49, energy and chemical reactions. So this is taking stoichiometry one step further. So it says determine the amount of energy released when 2 grams of potassium chlorate decomposes according to the thermochemical reaction below. So let's talk about this value right here. So that's an exothermic reaction, first of all, because it has a negative sign in front of it, so that means that it's exothermic. And what this tells me is that when this reaction happens once, I give off 89.4 kilojoules. Now in AP, we call this kilojoules per mole of reaction. But that's just sort of an AP thing. It's starting to catch on with some other places, but so that's how much energy I'm giving off. Now, what does that mean per mole of reaction? What that means is that I'm going to give off 89.4 kilojoules. That's for every 2 moles of KClO3, or 89.4 kilojoules for every 2 moles of KCl, or 89.4 kilojoules for every 3 moles of oxygen. So I can use these as conversion factors, right? So that's 2 moles of KClO3, 2 moles of KCl, 3 moles of oxygen, but I have 2 grams of potassium chlorate. So let's see how I can use this as a conversion factor. I've got 2 grams of KClO3. Let's convert it to moles because all of these are in terms of moles, right? So let's go ahead and convert that to moles. 1 mole. How much does a potassium chlorate weigh these days? Let's see. Molar mass of KClO3. Potassium weighs 39.10. Chlorine is 35.45. 3 oxygens, which is 48. Of course, I'm running out of room. 39.1 plus 35.45. And I get a value of 122.55 grams per mole. So 1 mole over 122.55 grams. So that'll give me the number of moles. So that gives me 0.0163 moles of KClO3. Okay. Now what I'm going to do is I'm going to use this and my conversion factor right here. That's the amount of energy per 2 moles. And I'm just going to convert my moles to energy because that's what I'm looking for. So I've got 0.0163 moles of KClO3. I give off 89.4 kilojoules for every 2 moles of KClO3. KClO3 cancels out. Moles cancels out because I should write a moles in here. There, now I did. So it's that value times negative 89.4 divided by 2. And I get a value of negative 0.729 kilojoules. So the negative just tells me that it's released, that I give off that amount. So that's how much energy I give off if I use 2 grams of potassium chlorate. All right? But let's look at the next one. What happens if we form 12 grams of oxygen? So how much energy? So I'm going to convert grams to energy, right? So that's 12 grams of oxygen, same reaction as above, 1 mole for every 32 grams, right? So that'll get me moles of oxygen. Let's go ahead and stick with that number. So that's 12 divided by 32. So I get 0.375, and that's moles of oxygen. Now I want to convert from moles of oxygen to energy, and it is negative 89.4 kilojoules for every 3 moles of oxygen. So it releases negative 11.2, we'll go to 3 sig figs here, 11.2 kilojoules of energy. Oxygen cancels out, moles is in here, it's sort of, okay? So there you go, working with energy.